Right, racing through the revision here. What is the equation of the line which passes through the point of intersection of the lines with equations 2x plus y minus 1 equals 0, 3x take y plus 6 equals 0, and is parallel to the line with the equation 7x take 4y minus 1 equals 0. So the wording threw a few people on this when I was having a little chat in class, but it really shouldn't. Look, what's the equation of a line? What do we need to define a line? Remember, we either need 2 points, or what do we calculate when we have 2 points anyway? We need 1 point and a gradient. If I have any point, once I tell you a fixed gradient, there's only one line you can draw through that gradient. If I told you it was a flat line, it would have to be that one. A vertical line would have to be that one. Gradient of -3, draw a line of -3. There's only one possible line once you have a gradient and a point. So, what do I need from this? Well, it passes through the point of intersection of these two lines. So let's set up a pair of simultaneous equations and find that point of intersection. 2x plus y minus 1 equals 0. And the other bit of information they gave me was 3x minus y plus 6 equals 0. Well, this is nice. The coefficients of y are already the same value. One's positive and one's negative, which means if I add those two equations together, equation 1 plus equation 2, I get 2x plus 3x is 5x, -1 plus 6 is plus 5, and of course my y's there, you notice they disappeared. Positive y, subtract y, they cancel each other out. 0 plus 0 is 0. Solving this is kindergarten work for each of you. Subtract 5 from each side, divide by 5, x equals -1. Once I've got that, sub x equals -1, I'm going to sub it into equation 1 because that's got a positive y term, and that's going to make my life a little bit easier. So if x is -1, I'm going to have 2 times -1 plus y minus 1 equals 0. Y minus 3 equals 0, so -2 minus another one is -3. Add 3 to each side, y equals 3. So I now know a point on the line. Point on the required line is going to be x equals -1 and y equals 3. Secondly, it's going to be parallel to the line with this equation. So 7x take 4y minus 1 equals 0. How do I get the gradient of that line? Because if it's parallel, then it's going to have the same gradient, isn't it? Well, we just rearrange it into y equals mx plus c. Add 4y to each side. 7x take 1 equals 4y. Divide by 4. 7x take 1 all over 4. I could write them separately or together, doesn't really matter. That is equal to y. Therefore, the gradient of this line is 7 over 4, and the gradient of the line that's parallel to it will be the same. So what's the equation of the line that I'm looking for? The equation I'm looking for is in the form y equals 7 over 4 x plus c. So I've got the gradient. I want to calculate c. What do? I sub in that point that we've been given. Sub in -1, 3 to solve for c. Once I know the gradient, if I can find a point on the line and substitute it in, I know that's going to be true. So this is going to work. So y equals 3, 7 over 4 multiplied by -1 plus c. I've got 3 equals -7 quarters plus c. So to get c on its own, what's the opposite of subtracting 7 quarters? Adding it. Well, this is already 12 quarters. So 19 over 4, 19 quarters equals c. So what does that make the final equation? Oops, my pen disappeared for a second there. It's going to be y equals the gradient 7 over 4, so 7 over 4x, and the y-intercept c, plus 19 over 4. And we're done. Let's go have a look in Desmos and see if it satisfies all of these things that we were looking for. Let's see how we go. So over here in Desmos, just to save a bit of time, I've got the equations all ready to go. So we've sketched the first two equations. We know that our line has to go through the point of intersection there. Well, what was the point of intersection? -1, 3, and if we check, yes, good, we got the point of intersection being -1, 3. Now the line we want needs to be parallel to this line, 7x take 4y minus 1 equals 0. Let's have a look what that is. So we want a line, let's move it down a bit, going through this point here, -1, 3, parallel to that one. If we click on the line we came up with, you can see that yes, they are parallel lines, and we've done a good job. The line parallel to this line and going through the point of intersection of the first two equations. Well done if you got that one right. Catch you in the next video, which is going to be question 8. Cheers.